Hello, good day. Our team is going to present our software systems design application project. Our app is called MedOnTheGo. The members of the team are Aruna, Ravi, Kumar, Karan Maria, Sirah, Micah, Elumba, Efrén Hernández, Anthony Dennis Mariadas, and Juan Pablo Hernandez. To start, we can talk about why did we choose the system. As a team, we decided to solve a current issue to make our system feel innovative and needed by the community. We had a meeting to decide our next steps and what system we can use. We talked about different issues, but decided to go with a really recent problem. After the pandemic, we discovered the need for applications that can work in a remote environment and have the ability to function with the physical contact, as well as have a quick and practical response for users of all ages. A system that supports the health system in Canada seemed like a good choice to develop an application. So now we can talk of what will this system do. After the COVID-19 pandemic, the people and the health organizations in Canada need new technology to establish a system that can provide a virtual platform for patients to receive consultation from doctors and to locate nearby drugstores. It is very time consuming for the patient to reach out to multiple clinics to check for doctor appointment availability for a particular period of time. When a patient is already suffering, searching for doctor appointments through other services like on your mobile phone is an added pain for the process. People are so using the MedOnTheGo app, at the click of a button, you can virtually have your doctor's appointment and even medication delivered to your doorstep. The app requires an internet connection and simple basic knowledge of browsing. This clearly thinking about the elderly people who need help in these times of crisis. An e-medical platform will be designed via a mobile app that connects users to doctors at the touch of a button, essentially eliminating the travel time and the risk of acquiring COVID-19. MedOnTheGo helps people to get connected by maintaining physical distance, which is much more necessary in this pandemic time. The app has the capability to connect patients with doctors and pharmacies. These patients can compare doctors' ratings and order their medicine online. Also, the doctors can provide consultancy online. Comfort from patients' home, less contact to avoid COVID-19, and an easy interface are the benefits for our stakeholders. We manage three subsystems to ensure the correct performance for our users. A login subsystem for doctors and patients, a payment subsystem for appointments and prescriptions, and a doctor appointment booking subsystem. So now we can talk about how do we approach doing analysis and design for this system. We start to work in our courses, in our classes, working with our material that the professor gave to us. We had weekly meetings with the professor. The professor gave us feedback about different parts of the process of the project, what to do, what to change. So we started with the requirements and the problem statement. Like I said before, when we started working on this project, we consider what is the problem and how will our solution work on it. Finding a concept for the project, we decided to go with a current issue, an issue that's been murdering the humanity for almost 2 years now, the COVID-19. With these symptoms that the COVID-19 have, and the solution to avoid physical contact, to have physical distance from other human beings, provide the necessity for this kind of app to work with an application for booking appointments online and then ordering medicine online. So we selected the health sector for this project. And after coming with the solution with the MedOnTheGo mobile service for health and medicines for appointments, we needed to go for the requirements and the problem statement for this issue. After stating the problem, the next step is analyzing the requirements. A non-functional requirement is the one that specifies criteria that can be used to judge the operation of a system, rather than specific behaviors. From our classes, we have learned that sharing one's information without their consent is an illegal offense. So, to avoid a data breach, in our project, we have considered the security for users, and without their consent, their information will not be shared. Talking about accessibility, our system is user-friendly, and we have designed it in such a way that even if the user is not much educated by the new technologies, he can browse without no problem. It's efficient, it has scalability, and our system will be developed both in Android and iOS so that both platforms users can download the application and use it. Our system also has the ability to match geological location and time. Talking about our functional requirements, we can cover the registration of users so that users can log in with their credentials. Also, we can see the ratings for doctors and selecting the list of doctors of their preference. There is the book of the appointment for a doctor consultation. You can also book an online delivery for medicines, and doctors can check medical records for the reference of their patients. So our project has covered both functional and non-functional aspects of this system. For the next part of our project, we needed diagrams to explain how our subsystems will work and the analysis of them before the design. So we start to use the UML language. The Unified Modeling Language is a general-purpose developmental and modeling language in the field of software engineering. This language is intended to provide a standard way to visualize the design of a system. The UML artifacts are built around use cases. A use case diagram is the example that we have in yellow in this slide. At the center of the use case is the one that connects all four artifacts views of the software architecture, which is typically shown using the UML standards for developing the diagrams. A use case represents the functionality of a system. After developing our use cases on our three subsystems, we create our domain class diagram. We learn that this diagram describes the types of objects in the system and various kinds of static relationships which exist between them. This diagram is the previous step to create an entity relationship diagram, which is the one in orange. An entity relationship diagram is a type of flowchart that illustrates how entities such as people, objects, or in this case, our doctors, our users, our appointments, our inventory, or pharmacy, these objects and concepts are related to each other within a system. ER diagrams are related to data structure diagrams, which focus on the relationship of elements within entities instead of relationship between entities themselves. They use a defined set of symbols such as rectangles, diamonds, ovals, and connecting lines to depict the interconnectedness of entities, relationships, and their attributes. After these diagrams, we needed a way to analyze how different use cases will work on our app. So we use sequence and state machine diagrams. The one on the left is a sequence diagram. These diagrams are a popular dynamic modeling solution in UML because they specifically focus on lifelines or the processes and objects that live simultaneously, and the messages exchanged between them to perform a function before the lifeline ends. An object responds differently to the same event depending on what state is it in. So, for this, we're working on state machine diagrams. These are usually applied to objects but can be applied to any element that has behavior to other entities such as actors, use cases, methods, subsystems, etc. And they are typically used in conjunction with interaction diagrams. So, a sequence diagram. Now we can talk about modularization. The modularization of a software design taught us how the system can be further divided into subsystems. It is considered as a best practice in software engineering to divide a larger system into subsystems and then integrate the components to form a software in such a way that there is low coupling and high cohesion in between the modules and components. Reducing the dependency between the modules and keeping all the related code together reduces the chance of the software to be prone to errors. It also makes it easier to update the code to introduce new features without changing the entire system. Improves the security of the software and shortens the development time. In our project, the system is designed in such a way that each class module performs only a specific function. The system is divided into classes on the basis of their functionalities. The architecture context diagram is the one that we have in the slide, let us see the bigger picture of the system. It defines how the system interacts with the external systems, the subordinate actors, and its peer system. It is necessary to decide the integration of the system in order to provide necessary provisions in the application and to decide the way the systems will communicate with each other. We have learned that to develop software, it is common for everyone to use their own logic, knowledge, and experience to create code. And this often results in complex developments that only its creator understands. But with the design patterns, it is possible to develop a module that another programmer can take advantage of to understand and improve. These are basically sample models that serve as a guide for programmers to work with. We have also learned about user experience when we saw that it was important to improve the quality and functionality of our products and services. With these points, we have learned to standardize a project using the best practices to have a high quality and scalable final product. In the next slides, I'm going to present the final product design that we decide to use for our application. So, first of all, the registration. We have here our interface to register our users and doctors. There is information, their gender, and how to register. Now, after they register themselves on the app, they can just log in and the registration will be complete. Also, we gave them a patient ID or a doctor ID, whatever is the case. Now, the home page. As you can see, we have 4 buttons. As we promised, we have a user-friendly application. The list of doctors, the book of an appointment, the search of medical products that also has an online delivery application, and of personal medical records. If you only want to search for a doctor, there is no rush. You just click on doctors, then you will see a list of different doctors around the country or your location, and then you can have a search list too to see all the doctors in all specialties. After you search for the doctor, you can book an appointment. As you can see on the left side, you can see the information of the doctor, the details, the qualification, what's his experience or her experience, and you can book an appointment. You will put your data, your doctor's name, the appointment's date, what are the amount to pay, and you can pay right there. After all this process, your booking will be complete and you will have your appointment very soon when you wish to. Now, after all this process, we can only think, if we could do it again, what would we do differently? Well, first of all, we will make a larger system with more subsystems to support our patients and doctors. As an example, we had a system in the early stages of this application, the beginning, the initial designs, a system for locating clinics and pharmacies. But over time, it was discarded to focus on virtual appointments and prescriptions. Similarly, we thought of having a system in which the government could promote the COVID-19 restrictions in real time for the entire public, as well as being able to schedule vaccination appointments in different parts of the country. Apart from the systems in this design theme, we believe that there could have been a greater organization among the team members to achieve better project development. But despite the situations, we believe we achieved our goal, which was to create an app with a medical approach to help the community in these times of crisis. So now the question is, if we secure funding to build the system we designed, what are the next steps for software engineering perspective? Well, I think the next step will be to form a bigger team to be able to focus the development of the programming of our application. Once this team is formed, the following steps could follow an agile methodology to achieve the expected results. During these previous months, we created the basis for what our application would be and what design we wanted to achieve, for which the implementation of our analysis and design will be in the different technologies that we chose throughout the semester to develop the different planned systems. We will use MongoDB, JavaScript, some software to develop a mobile application on iOS and Android. And after this implementation, it will undergo a review and retrospective to continue moving forward with the project. Of course, we will inspire our methodology in the Scrum to be able to manage the different processes of our application. So it just left to say thank you for your attention. It has been a really challenging but interesting project to work on. Developing an app is a really interesting task. We learned a lot about the process, about the agile methodology, about how the software works, what are the different parts of it, and we hope that we can keep working on this in a near future. So thank you and have a good day. Thanks.